All right, so for today's lesson, we're going to be looking at systems of equations. So when we talk about a system of equations, we're really talking about how two or more equations are used together to find an unknown value. Now, for our class, we're going to focus on two equations, but what is a system? So normally when I think about a system, I think about a school system, where in your school system, you have multiple different pieces and parts and people that make a school system work. So we're going to learn how these two equations work together in order to come up with a common solution. So we're actually going to start with a tree map, which is going to show the three different categories or three different ways that you can see a system of equations.
So the first way is going to be when they intersect one another. So when they intersect one another, and we're going to kind of start off talking just about linear, and then we'll look at a few examples later on with linear and quadratic or linear and exponential. So when we're looking at the intersect, so what happens when a system intersects each other? Well, when they intersect, and when we're talking about linear, we're talking about the fact that it's going to have one solution. So this is going to have one solution, and that solution is actually going to be on your graph where my two graphs intersect each other. Where they intersect or where they are the same. So if they are the same, then those two pieces have the same point at that intersection right here. Okay, and that intersection can occur in a lot of different ways. But when, let's say if I give you the example and I have y equals 3x plus 1, and I have y equals negative 5x minus 2. So if I come over here in Desmos, I have y equals 3x plus 1, and I have y equals negative 5x minus 2. So I can see there are lots of intersections going on, and I don't want to know where it's intersecting the x-axis. I don't want to know where it's intersecting the y-axis. Those are x and y intercepts. What I want to know is where are these two lines intersecting each other. Where they intersect each other is where the system is going to occur, where that solution is. So as I zoom in, I can see, and you got to be very careful because sometimes, you might accidentally wind up clicking an x-axis or a y-axis. But you're going to find that solution by looking for the intersection. So that intersection point to that solution is negative 0.375, and we have negative 0.125. That point, my x and y value, are the solutions to my system of equations. Okay, and again, we're going to talk about a lot of different systems. We're going to talk about a lot of different types of functions that we're going to graph. But the first way is when they intersect. That intersection is the solution. All right, so the next thing that we're going to talk about is we're going to talk about parallel. Now, if an intersection is the solution and my lines are parallel lines mean they're never going to intersect. So if they're never going to intersect, that means that they're never going to have a solution. So that means no solution. And again, the reason we have no solution is because if I were to create my graph, my two lines are never going to intersect, so they're never going to be the same at any given point. Okay, so that no solution, that means that technically they should have the same slope. Remember, we talked about parallel lines when we did linear. Parallel lines have the same slope. And let's say I ask you to look at y equals, we'll do 3x plus 1 again, and then we'll do y equals 3x minus 5. Okay? So if I have those two pieces, then I have y equals 3x plus 1 and y equals 3x minus 5. And I'm going to kind of hit the home button and go back. You should see that those are parallel, and you should see that they're never going to intersect. So therefore, no solution for that system of equations. They are never going to be the same values that will hold true for those two equations. Okay? And then the last situation that we can have is going to be same graph. So what do I mean by same graph? Well, same graph means that they are going to be overlapping. And if they're overlapping, that means that they are going to have infinitely many solutions. Now, the reason we say infinitely many solutions is because no matter what point I have, that point will work for the other graph as well because they're on top of each other. So if I look at a graph for that one, and let's say this is my graph, and I graph another one, and that one winds up being right on top of it. Okay? So therefore, no matter what point I pick, I could pick this point, I could pick this point, I could pick this point, whatever point I pick, it will have that same solution. So when I'm looking at this, these are overlapping because they are the same line. All right, so if I look at this problem, also for infinitely many solutions, we could call it IMS for short. And let's say I have y equals 3x minus 3, and I have y equals 3 times x minus 1. Now, obviously, if I were to simplify this, then I can, I should be able to see if I distribute that it's the same line, but I can type it into Desmos exactly like I see it. So I have 3x minus 3, and y equals 3 parentheses x minus 1. And you should see over here I have the black line and I have the red line, and I can actually change this. We'll make it blue. So I have black and blue. If I turn these off, so like the red one, if I turn it off and on, I can see that it is most definitely on top of the other one, and I'm turning it off and on by clicking that circle. And that gives me the exact same line, which is infinitely many solutions. Now, given that, we're going to look at a bunch of different pieces, and we're going to look at some equations and answering these, being able to determine how many solutions. Is it one solution, no solution, infinitely many? We may have more than one, and we're just going to go through a few problems. All right, so here's two problems that I have. So it says, what is the solution? Okay, so we're looking for the solution to the system of equation below. Now, one thing I want to draw your attention to for this first equation right here is in slope-intercept form. The second equation is in standard form. That is okay because we're going to look at it graphically, and Desmos will graph both of those. So I'm going to go put it into Desmos, and I have y equals 6x minus 9, and then I have 8x plus 6y equals 12. And I should see that there is clearly an intersection here. So the question is let's make sure we zoom in and make sure we get that intersection, and we have 1.5 and 0. So my solution point is 1.5 and 0, which is D. Okay, so now we're going to look at the next one. So the next one, when I'm looking at this one, I should see that there's a little bit of a different type of equation here. It doesn't really matter that it's different. We're still looking to solve the system by graphing. So I'm going to type the first one, so y equals, and we need x squared. So we're going to type x, and then I can use this a squared or a to the b, either one. The a to the b is for any exponent, plus x minus 2. And this is actually going to give me a quadratic. We have not gotten to those, but you should still be able to graph it and look and apply the process. And y equals negative x plus 1. So I have a line and I have a quadratic. Now, as I zoom out, I should see that this is actually going to be intersecting at more than one point. So if it's intersecting at more than one point, that means that it is going to have more than one solution. So when I click here, there's that first point that they're intersecting at. So my first solution is going to be negative 3, 4. That's my first one. So I'm going to zoom in a little bit here, make sure we're good and on top of that one. And my second solution is going to be 1, 0. So this one has two solutions. Now, I'm going to adjust this for a second, and I'm going to change this, and I'm just showing you what would happen. So like, let's say that I graph this line. These are never going to intersect. So since there's no intersection, that means that there is no solution. This can't have infinitely many because they can never be the same graph because one's a line and one is a quadratic. But the rule still applies. Where they intersect are the solutions, and those are points. If they don't intersect at all, then that is no solution. Okay. All right. So then we have the next two. So this one says, which system of equations has exactly one solution? So how do we figure out which one has exactly one solution? Well, we would need to go through the process of graphing these. And in graphing these, we are going to look and analyze the relationship that we see. So this one, I'm seeing that the two graphs are on top of each other. So if they're on top of each other, that means they're overlapping. So if I go back, and overlapping is this one right here. Okay, so if they're overlapping, that means it's infinitely many solutions. So this one is actually not going to be one solution. This is going to be infinitely many. So A is not going to work for us. All right, so I'm going to now go to B. And I have these two equations. And again, I can see they're overlapping. So if they're overlapping, that means that they are the same line multiple times, or have multiple points, infinitely many points. So that's not going to work. All right, and we're at C. So C, here's C, and then I notice these two are never going to intersect. So if they're never going to intersect, then that's going to come back over here to this piece right here, which is going to be no solution because they're parallel. So if they never intersect, that means no solution. So this one is going to be, whoops, no solution. That's not going to work because we're still looking for one with one solution. So we're going to go back to D, and at this point, process of elimination, this should be the right one, but let's make sure. All right, and we should see that these two lines intersect, and they intersect at one point, and that one point makes the correct answer D. Whoops, and actually I need to change that, but either way, this is still going to be my point. My solution is where they are intersecting, and there's your answer. All right, and the last one. It says, what value of y? So that is one thing that you've got to make sure you pay attention to instructions. Sometimes they may ask you for just the x. Sometimes they may ask you for just the y value. So make sure you're reading and make sure you're looking for that particular piece. Now, it's not asking for an x-intercept, so not the y-intercept and not the x-intercept. It is asking you for the solution point, so it's asking you for the intersection. But that intersection, it's asking you for the y value. So it's asking you for this piece right here. So do not confuse what is the y as the y-intercept. We're not looking for a y-intercept. Okay. So I have y equals, I have 4x minus 2, and y equals 3x minus 1. All right, so you may have to zoom in because this one, there's a lot going on here. So you could like accidentally click some points that you didn't mean to. So I'm going to zoom into that intersection, and I find that the intersection is 1, 2. So 1, 2, you can see that 1 and 2 are both answer choices asking for the y value, so the answer is 2. All right, if you need any help, make sure that you send reminds, send emails, log into Zoom office hours, and make sure you get that extra help.